Biofuels like bioethanol and biodiesel are key contributors to a low-carbon transport in Europe. By 2021, they provided the lion's share of more than 90% to all renewable energy in the European transport sector. At combustion, biofuels only release the amount of carbon to the atmosphere that has previously been absorbed during growth of the feedstock plants. Even when including the emissions caused by cultivation, fertilizers, processing, and transport, the remaining carbon footprint is still smaller than fossil alternatives. However, this advantage has been persistently disputed over the last decade and a half. Critics claim that if farmland is used to grow biofuel crops, this will displace food crops that were grown before on the same patch of land. Less food crops on the markets translates to higher prices, which again will incentivize farmers, especially in the global south, to convert natural landscapes for agriculture in order to meet the additional demand. This indirect effect of growing crops for biofuels is called indirect land use change, or short iLUC, which then causes carbon to be released from soils. By allocating these emissions onto the use of biofuels, their carbon footprints may be even higher than fossil fuels. Environmental organizations have hence argued that biofuels actually harm more than they help, and thus should be banned. Sounds plausible? Well, that's actually far from certain.
So these indirect effects are speculative, and that's what we usually try to keep out of fact-based assessments like LCA.
This is Professor Matthias Finkbeiner, researcher at the Technical University of Berlin and one of the world's leading experts in the field of life cycle assessment, or LCA, a method of sustainability assessment.
First of all, these indirect effects are usually not measurable. They cannot be observed. It's just a plausible argumentation chain, because in life cycle assessment, we try to capture real material and energy flows and real emissions, measurable.
While direct land use change is well measurable, in the case of iLUC, there is no direct energy or material flow connecting land use change and the energy crop cultivation in different parts of the world. Therefore, researchers tried to approximate these market effects using economic models.
There are this kind of macroeconomic model which basically model this economic effect with this macroeconomic input-output tables, and they are in general very coarse, very looking into sectors, and there are obviously a lot of uncertainties involved.
Indeed, a lot along the chain of effects can go differently than modelled. Among others, farmers may accommodate biofuel crops by increasing yields rather than by displacing food crops. The land used for agriculture globally differs each year. Market prices are impacted not only by biofuels, but are much more fluctuating due to a multitude of other causes, such as natural disasters, shifting consumer preferences, trade policies, wars and conflicts, mere speculation, and many more. Also, carbon flux from soil can vary between locations. With this level of uncertainty, the actual information contained in the iLUC estimates is of little use.
That's why also these iLUC factors based on different models vary significantly. They vary between orders and magnitudes. They vary even between negative and positive factors. There is a fundamental problem with this indirect effect, as I said, because it's a prediction of a future, and it's a prediction of one plausible chain of action, but there are also always in life, there are several. So I think there are actually quite fundamental limits that you can measure these indirect effects at all. For my state of knowledge, as of now, they will never be measurable.
Meanwhile, there are further issues with including indirect effects into carbon footprints.
If you would try to start to include indirect effects in general in these assessments, you could economically argue that even for a windmill and renewable power plant, you make the coal-based power cheaper, and then you allocate some burden of this cheap coal power to the windmill. This is a similar economic effect which is used for the indirect land use change.
But why do we care about iLUC at all? And what would be an effective countermeasure? Finkbeiner calls for local action, directly where the land use change is actually taking place.
And there, the societies, they use their land to sustain their living and to sustain their family. And so land use change, of course, is an issue for climate change and for biodiversity. But you have to make policies on the ground. They have to be managed on the level of direct land use change and the land use change measures in the countries.
Banning biofuels instead is only an indirect countermeasure with effects as speculative as the iLUC theory itself.